Question 18 is to find determinants and inverses of matrices. It is from lesson 5.2. Here we have got two matrices. You can see it's matrix A and B. They both are 2 rows, 2 columns. Now we need to find whether they are inverse of each other. There are different methods. Exactly, they have not specified which method to use or anything. So one method would be finding the inverse of this matrix using formulas, and if you get this, yes, that is true, otherwise no. I'll do that method, but the first method, the basic method, is multiplying them both. You multiply AB, and if the answer is I, identity matrix, and also if you multiply B and A, then you get I, then yes, it's inverse of each other. Now how do we multiply? See, multiplying matrices, it's easier if you have them together side by side. It's 12 minus 5 minus 7, 3 over here. And this is 3, 7, 5, 12. Now what you do is the first row with the first column. So 12 times 3 plus, this is the tail, head and head. Minus 7 times 5. That's the first newly formed digit of the matrix. And next one, the same row with the second column. It'll be 12 times, leave some space, 12 times 7 plus minus 7 times 12. And then the below row with the column, first column, it'll be minus 5 times 3 plus 3 times 5. And lastly, we have got minus 5 times the last second row, that is minus 5 times 7 plus 3 times 12. This is it. Now you can just put this in the calculator and solve it up. Let's see over here. 12 times 3 is 36. 7 times 5 is 35. So, sorry, 7 times 5, yeah, 35. Minus 35. So over here we have got 36 minus 35. And here we have 12 times 7, that is 12 times 7 and 7 times 12, and minus is there, so it becomes 0. They cancel off. It is 84, 84, 84 minus 84, 0. Over here, 36 minus 35, I'll directly write it, it's 1. Here this is 1. And what about this one? Same thing, it cancels off, same number, 0. And over here you got 7 times 5 is 35. And see, minus 35 and positive 36 will be positive 1. So yes, we got the same thing. This has to be multiplied, A multiplied by B. So AB will be equal to I. Now the same thing needs to be done to B and A. Now here, this was the first step. Step 1, find AB. And we did. This is A, this is B, and we multiplied and we solved. It is identity matrix. It is equal to I. This is equal to I. That is 1, 0, 0, 1. Now you need to do B and A. Step 2, it'll be find BA. B and A. So B will be second matrix over here. Matrix B is 3, 7, 5, and 12. And then we have A, that is 12 minus 7 minus 5 and 3. So now let's take this with this. Here we have 3 times 12 plus 7 times minus 5. Then the second one will be 3 times minus 7 plus 7 times 3. Then we have 5 times 12 minus 12, sorry, it's plus 12 times minus 5. And lastly, we have got 5 times minus 7 plus 12 times 3. Let's see, this 12 times 3 is 36. 35, again, it's 1. Cancels, same terms, 0, 0, and minus 35 plus 36 is 1. So again, we got I. This is I. So this was by multiplying B and A. So BA equals I. Now what you can say is, because AB equals to BA equals to I, they are inverse of each other. They are inverse matrices or inverse matrices. You can write it from the question itself. So this is the thing, inverse matrices. So this is how we solve it. Now when they are inverses, when you multiply them, you should get identity matrix. That's the main concept. Now this is absolutely fine. Now you can do any other method as well, as long as you know whether they are inverse of each other. That is it, right? So what I'll do is I'll do another method. Now this method is important because inverse is generally found by this method. And even if two matrices are given, absolutely you can find it. And now here what happens is step 1. Find determinant of matrix A. Find the determinant, just this much. Determinant. Now we know this is inverse, so what happens is I'll try to find the inverse over here by the formula, and whatever I get must be the matrix B. If I don't get, then it's not inverse. So find the determinant. How do I find the determinant? The formula is, now here if you have A equals A, B, C and D, then determinant A would be, or you can write magnitude, it's the same thing. Determinant can be also written as like this. This is called determinant A, will be equal to A times D minus BC or CB. It's the same thing. Okay, this is the formula. Now let's find. Determinant A will be equal to 12 times, let's multiply these two. 12 times 3 minus, don't forget the sign minus. It is minus 5 times minus 7 or minus 7 times minus 5. It's the same thing. So over here we will have 35, over here it is 36. 36 minus positive 35. The answer is 1. Determinant is 1. Therefore, inverse exists. You just write this. What does this mean? Look, when we find the determinant of any matrix, if we get this of, when we do the determinant, we get 0, then there is no inverse. It cannot be possible. When you get any other value like a negative 5, negative number, positive number, any number other than 0, there is inverse. So therefore, we tell this 3 dots means it's therefore, or you can just write hence. Or even if you don't write, it's fine. You just continue to find the inverse. That's it. But if it was 0, then you stop. You tell there is no inverse. Why? Because you cannot find the inverse, because over here there is 0. So this is the step 1. I hope this is clear. You can pause the video, write it down if you want, because I'll move to the step 2 now. I'll clear this off. Please remember it's 1. Keep it in mind, but you can see it, refer it later. The step 2 is to find the inverse. Find the inverse. Which inverse are we finding? It is the same matrix. It is of matrix A itself, because we found the determinant of A. The formula is given here. If we have A, B, C, the same condition. If you had A, B, C, the inverse, A inverse is, see the symbol, A raised to negative 1, that's the inverse symbol, would be here the swap. D, A. Instead of A and D, they swap out. And what about the B? It just becomes negative, and the C as well negative. Okay, I forgot to write the determinant. It's all divided by or multiplied by 1 by determinant A, or divided by determinant A. So this is basically the inverse. This is the formula. Now we know determinant A was 1, right? So here 1 by 1 will be equal to, what happens? It'll be 3, 12, minus becomes plus 7, plus 5. That's the answer. Now multiply this 1 by 1. Anything you multiply, it's the same thing. So the answer will be 3, 7, 5, 12. This should be the inverse. Let's just check it with B. Yes, absolutely, it's the same thing. So this is A inverse. Now what you can say is, hence A and B are inverse matrices. Inverse matrices. So now even if you write these two steps and solve it like this, it should give you full marks. Just make sure you let your teacher know if they are okay with this method, because absolutely this must be okay. Because any method you do, as long as you tell these are inverses, it's true. Why you can tell? Because A inverse is 3753, right? Now if I find the inverse of this, I'm going to get back A itself. Now no need of doing ABA, because the multiplication at times tends students to do simple errors. A sign might miss or something like that. So this is a confirmed way. Yeah, matrices can be easily solved in calculator as well, but I'm not going to tell any calculator method here because it's the writing part. But for the electronic part, all the matrices, I will show you the calculator method and I will solve it by calculator method itself. So we'll move on to the next problem. So they are inverse of each other. All these are the same thing. Now we have plenty of same type of problems. All you can do is multiply these both, or you can find the matrix of A, and if it matches, yes, that's your answer. So here we go. Here they are inverse because both the time you got identity matrix, or if you quickly find the determinant and solve it up, you must get each other. So here, let me just find the determinant first. 3 times 4 is... See, now I'm not going to write in steps. Whatever I wrote for the first problem, please maintain that. Write it in steps, everything in detail. So when you're solving these problems by yourself, write it accordingly. But now over here, I'll just write it very quickly. It'll be minus 5 times minus 4 minus 6 times 3. It'll be 20 minus 18, so it's 2. Inverse exists. So let's see whether the inverse is true or no. It's a 1 by 2, and here we have minus 4, minus 3, minus 6, and minus 5. Absolutely no, this is not the right one. It is, when you multiply half, it's going to be minus 2, minus 3 by 2, or 1.5, minus 3, and minus 2.5. They don't match. So this has an inverse, the matrix A has an inverse, but it just doesn't match with the given matrix. So here they're not inverses. Now even if you do this method multiplying, you will get some other answers, so they are not inverse. Here as well, it's the same method. You can quickly do it by yourself and then check. You can also use the below term. Now for example, this one, you can find inverse of B. And if it is A, then yes, otherwise no. So first let me find determinant of B. The two lines modulus means it's determinant. So it's going to be minus and minus plus 9 minus 10. That is minus 1. So here 1 by minus 1. And what are the terms? We have to swap these two. Minus 9 minus 1. And over here it will become minus 2 minus 5. See, here it's... Don't think it's wrong. Okay, I did a mistake. These two swap, and yeah, now it's all right. Now this is absolutely... don't think, okay, we're not getting the sign, but remember there's minus 1 outside. When you multiply it, it's going to be 9, 2, 5, and 1. So yes, this is the inverse itself. 9, 2, 5, and 1. I hope this is clear. So they are inverse of each other. If you multiply, you'll get I. Now, similarly, please solve this problem over here. You will be stopped at the beginning itself because over here they are not inverse of each other. You're not getting identity matrix, therefore they're not inverse. Over here they are inverses, and over here they aren't. Now, remember, there might be a situation where when you find determinant A would be equal to 0. And in such case also there is no inverse. It's not only that you'll get some inverse and it doesn't match with B. No, it's not only that situation. Even when you have a determinant of 0, that's not the inverse of each other. Now these type of problems we have to do in the method which I just showed you. Let me solve this problem here. So step 1, find the determinant. And what you need to do is to find determinant of A. I'm not going to write the formula. I'm directly solving it up. Minus 4 times 3. But in the exam, better to write the formula. Write a matrix A with ABC, ABCD, and then write the formula. It is A times D minus BC. So minus 4 times 3 minus 6 times 2. And now minus 12, and this is minus 12, but you add it up with that plus 12, so the determinant is 0. There cannot be inverse. This is a singular matrix. When there is no inverse, we call it singular. When inverse doesn't exist means when you get a 0 at your determinant. Because this is 0, we can tell it is a singular. See, this is the answer. Here they have done row transformations. It's absolutely fine. You can do this, but row transformation just takes time, and many of the times students might tend to choose these numbers wrongly, and then it's just confusing. So what I would suggest you is stick to this method, and this also gives you the correct answer. It doesn't matter which method you use, as long as you do in writing correctly, it's fine. Now here, that's the row transformation. Same thing here. Let's try this one. It'll be determinant A will be equal to 4 times, it'll be 8 positive minus 8. Now again, this is singular, it's 0, matrix is 0, so it's singular. I hope this is not singular. I don't think so. This is singular. So it's 5 times 3 minus 9 minus, and again we have minus 10. Now when you add it up, minus 9 plus 1 plus 10 is equal to 1. So this is how we found the determinant. Now all you do is swap these up. 1 by 1 multiplied by minus 3, 3 minus 5, 2. Because when you multiply minus with minus, it becomes plus. So the final answer would be 3 minus 5, 2, and 3. So this is how we solve this matrix. I hope this is clear, the inverse of this matrix. Pretty simple. Okay, did I miss something? What did I miss? Okay, I'm just very tired and sleepy. Maybe that's the reason I missed it. It's minus 5, minus 3, 2, and 3. Yes, it's minus 5, minus 3, minus 5, 2, and 3. Here they are doing the check or the verification by multiplying A with A inverse, which we just now found. And you must get I. Yes, of course you'll get I. And similarly, you're doing it with A inverse and A. Now you don't need to do this check as long as you write this properly and find the, so not this part, you find what is the inverse. Just find the determinant. If determinant is not 0, you will find the inverse. Look, it's better to stick to this method with the formula, because this method is useful even later on. Now here also the same thing. First you need to find the determinant and then use the inverse formula. So you can see here, and you will get some answer. So these both are, this is having inverse as well. Which is the inverse? That's over here. So 2 minus 5 by 2 minus 3 and 4. Even you can do it quickly here. Let's do this quickly. 8 4s are 32 minus 6 5s are 30. So the answer is 2, determinant. And then we just swap it out. 4, 8 minus 5 minus 6. But what do we have to do is 1 by 2. So half of everything. So it's going to be 2 minus 5 by 2, or 2.5. And here minus 3, and lastly we have 4. So that is the answer. And let's just check we got the same thing. Yes, it's 2 minus 5 by 2 minus 3 and 4. You can easily do this, but if you're going to do this method, it takes a long time because you need to do transformation of each and everything. So I would suggest you to stick with the formula method. We have 3 cross 3 matrix here. For 3 cross 3, I will tell you how to do the determinant easily in a different method. And then for the inverse, you can just use your calculator. Because otherwise, the row transformation, I'll just show you, it just takes such a long time. You can see here. And I'm sure it'll just take most of your time in the exam. You won't be able to do any other problem. All this just for that. And then if you verify it, it's gonna, take such a long time. What I would do is, you solve it in writing, the determinant, and then inverse, you just use calculator. Most of the time, almost always, these 3 cross 3 won't come for your exams. 3 cross 3 is generally not asked. So you can just ask your teacher beforehand, tell them the determinant you will do it manually, but the inverse, as in the textbook, it is clearly showed that use graphing calculator, so we'll use the calculator method only for the inverse. Now here, the determinant in your textbook, it is a little different. You have to take this first term, then find the determinant of the remaining terms, these two, then this term, and ignore those and the remaining determinants and all that. It's very lengthy. So there is an easier method. Write the matrix -1, 3, 2, -1, 6, 1. Then we have -3, 4, 8. I've written only the 3 columns. You need to repeat these columns. The first column here, again, I'll repeat it. First and second only, not the last one. So again, you're writing -1, 3, 2, and lastly, -1, 6, and 1. Now here, let me just change the color. Let me take this one over here. First, you start with upside to draw a diagonal line like this, slanting line. First row and first column, and then over here the second row and the second column, and the third row and third column. These 3 are together, and the same thing over here, these 3, and lastly these 3. What do? Is you start with up to down. First up to down. Now if you go down to up, the answer will be wrong. It will be opposite sign. It's from up to down. Now let me write it. It will become -1. You multiply all these. -1 times 6 times 8 plus -1 times 4 times 2 plus -3 times 3 times 1. That's the thing. Next, let me just change the color over here. This whole thing is subtracted with, let me consider here, from the down to up. So this was up to down. This one. So these 3 now rows, these 3 lines. I hope this is clear. It's now minus, I'll put a bracket because minus will be multiplied, 2 times 6 times -3 plus 1 times 4 times -1 plus we have 8 times 3 times -1. These are the answers. Next, you just put them in the calculator. You can solve it up, or you can do it one by one. It's up to you. So here what I'm going to do is 8 times 4, it is 48, minus, it's -48. Then plus, over here it's minus, so it'll be -8. Minus 3 times 3 is 9. Subtract the entire thing by this. 6 times -3 will be 3 times 2, 6, 6, 36. But it's -36. Plus, again there's -4 and this is -1, so -8 times 3 is 30, 20, 24, and here it's gonna be 48 and 8, 56, 56, 60, 48 for 65, yeah, -65, subtracted with 36, 40, 60, 64, -64. Now what you do is you have to do this minus, it'll be -65 plus 64. The answer is -1 here. The determinant, so you can write determinant of A is equal to -1. This is the step 1. Find the determinant. Find determinant, right? Now next one. After this, you should just write it down all along, and then clearing this, you write step 2. After this entire thing, you write step 2, find inverse. See, now the formula, it's just very, very crazy formula. So we're not going to use the formula. We'll just directly use the calculator. I'll even show you to check the determinant and the inverse in the calculator now. First thing is mode. In this mode, you can see matrix is at option 6. Press 6 and fill in the first matrix. That's option 1. And what is it? It was 3 cross 3 matrix. You can see the first 3 columns over here. It's 3 cross 3, it's a 1. Now type in the values. It's -1. Then when you press equal to, it goes to the, so -1 equal to, it goes to the next column, the digit over here. That is going to be minus 1 again, and then we have minus 3. The first row is done. Now you go to the second row. It's 3, 6, 4, and 2, 1, 8. Okay, so now press AC. That's saved. Now please don't go back to mode anymore. If you go to mode and 6 again, that will be an error. You won't, the matrix will be unsaved. Now it's saved. You should just press shift and 4 anymore if you want anything with matrices. Now here the determinant is given by option 7. Press shift and 4 again for matrix A, close the bracket, and look what's the answer. It's minus 1. Yes, absolutely. How do you find the inverse? It's just by shift 4, type in the matrix which you want to find its inverse, and inverse symbol is over here. That's the answer. So here next what you do is you just write this answer out over here. You found the determinant, write the answer. That's enough. So let's just look at the inverse. Where did we get it? Here one. Minus 44 minus 5 minus 14, 16, 2, 5, and 9, 1, 3. Absolutely the same thing. So this is how you can find the inverse of 3 cross 3 because it's very huge, and if you do it manually you won't get time. So do this method. Determinant is very important, this determinant part. Okay, this is simple, up to down, minus down to up. But it's just that you should copy these first two columns again after the third column. See, it's 1, 2, 3. Again it starts with 1 and 2, and then you solve it up. So this is the answer here. Hope this is all clear. Let's do one more. Let's find the determinant of this one. Again, first write 4 minus 2, 6, 2, 3 minus 1, 1, 5 minus 4. You get again 4 minus 2, 6, and 2, 3 minus 1. So not down to up, it's up to down. 4 times 3 times minus 4 plus, you can directly write over here the multiplied answer instead of writing all the terms. 5 times 2 is 10, 10 times 6 is 60. So we will directly write 60 plus 2 times minus, oh yeah, it's 2 only, but minus and minus will be plus 2. Minus, what's the values here? Down to up. So always you start with up to down. Come from here to down, then down to up. 6 times 3 is 18 plus, but there's minus, so I'll write minus 20. Then we have plus 8, 16. So here 16 times 3, 32, 48. It's minus 48 plus 62. Minus over here it's 20. Okay, there is minus and plus, so it's going to be 20, 34, 14. Positive 14. And what's going to happen over here? That's going to be 62. So it's 10, 12, 14 as well. Oh, I think so it's going to be 0. So it's 14 minus 14, it's 0. This means this doesn't, it's singular. So it's for such problems, when you find the determinant at 0, you write this is singular. Why? Because this cannot be transformed. Okay, now you can see the answer, there is no answer here. Whatever you do, your answer won't be. So you can see that there's no way you can get an identity matrix over here. There's no way it can be formed by, you can get 1, 0, 0, 0, 1, 0, and 0, 0, 1. So therefore you tell this is singular. Singular is very important. Similarly, please do try these problems by yourselves. You can see here, again the row transformation is done. It's again singular. If you do the determinant, it will be 0. You can check in calculator as well. So here now, okay, this has the answer. This is the answer. Sorry, I have to see the previous one. See over here, left side, when you transform it to identity matrix, whatever is the right side is the answer. Okay, so that is the inverse matrix. Left side, you have to get 1, 1, 1, 0, 0, 0, 0. In the previous one, whenever it's singular, you can see there's no way you can get it into identity matrix. It's just not possible. How much ever you try, one of the rows will be all 0. That means if you go ahead, there's no point. And so this is then confirming, you just multiply those both matrices and you will get identity matrix. Now we are back to the normal ones. Again, I'll do this problem quickly, not in steps, but when you're doing in your exam, you have to do the steps. So determinant A will be equal to minus 12. 6 times minus 2 is minus 12, minus and minus 15 again. So it'll be minus 12 plus 15, that is 3. Here determinant is 3, so the inverse will be 1 by 3. The swaps minus 2, 6, 5 and minus 3. So the answer is minus 2 by thirds minus, it's positive 5 by thirds, minus 1 and 2. Why? Because you multiply here, minus 2 by thirds, 5 by thirds, minus 3 divided by 3 is minus 1, and 6 divided by 3 is 2. So that's the answer. Here you go, that will be the answer. Be careful with the signs, and please, over here you can see that's the exact method which we do. This is the formula, this is the determinant. Both needs to be done, and that's it. If the determinant was 0, it's singular, you don't have an inverse. And this is the, see, you don't need to do this multiplication, because in this method, when you use the formula, that's it. In this, we already tell when it is determinant, when it's not having a determinant, there is a matrix. So that is it. Okay, if you want confirmation, just do it in the calculator, and you can tell using the calculator also you got the same answer, but you can just stop it over here. This is unnecessary. Please try these by yourselves. It's the same method again. Here you go, the answers are already there. You can pause it and check through the answers. And okay, now we have another interesting problem. We have to find the area of each of these triangles with vertices x1, y1, x2, y2, x3, y3 by using, see, area by this formula, half of determinant, this region. See, whenever you have coordinates, you can write X matrix where all the last ones, last coordinate 1, 1, 1, but this is x1, y1, x2, y2. It's up to you to choose. Choose this x1, y1, x2, y2, x3, y3, or you can even change it, doesn't matter, you'll get the same answer. Okay, I just randomly chose here because 1, 1 is simple, that's why. But you can even choose this as x1, y1, x2, y2, x3, y3, you will get the same answer. What happens is, first you need to find the determinant of this matrix. The matrix will be, so now 1, 1, 1, 4, 3, 1, and 4, minus 1, 1. And we need to repeat it again, 1, 4, 4, 1, 3, minus 1. And now up to down first, up to down. Here it will be 3 plus 4 minus 4. This entire thing is subtracted with down to up. 3 is a 12 minus 1 plus 4. So these and over here. And now then 3 plus 4 is 7, minus 4 is again 3, minus, here we have 3 and we add it up, it will be 15, minus 15. The answer will be minus 12. Let me just double check this. It's 3. Okay, one more thing. When you're writing these two columns, make sure it's this column in the fourth place and the fifth one, second one in the fifth place. That must be, it must be the same thing. If you just rearrange even a single digit, your answer will be entirely wrong. 4 times, okay, we start with up to down. It's 3 only, 4 minus 4, done. Minus of 4 times 3 is 12, minus 1, positive 4. Okay, that is the answer. Now then, you got the determinant to be minus 12. Here, can you see this magnitude? Now, after this, this is your step 1. Find, step 1, find determinant x. Okay, we just found it. That is determinant x is equal to minus 12. Step 2 would be, I'll just write it out over here. Apply the formula. Apply area formula. Now what happens here is a is equal to half, write the formula, magnitude of determinant x, not a. So here it will be half of magnitude of what? Minus 12. Magnitude means whatever is the sign, minus or plus, just takes the positive value, because determinant can be negative or positive, right? but area will be positive itself. So this is positive. Half times 12, that is 6 is the answer. It should be 6, the area over here. So you can see, writing this determinant first like this, and then what we do is, now this is the determinant long method. You take the first term, write this formula. It's just too lengthy and it takes more time, and there are chances you will make a simple mistake anywhere over here because it's plus minus plus. This one over here, whereas it's very easy, up to down, minus down to up. That's it. If you just remember that, it's very, very easy. Then once you find the determinant, it was minus 12, then you put it in the formula, it'll be positive 6, which is the same thing what we got. That's the answer. Again, there's another problem. Guys, you can try this by yourself because it's just same thing. You just apply over here 1, 6, 6, 4 and 2, 0 and you solve it up. The way you can see this, the long determinant method or the short one, which I'm telling you, it's the same thing. Here you first write it out. You can even interchange this. You can write 2, 0 first, 1, 6 down. It will be the same answer. And then after finding the determinant, you use the formula. Its determinant is minus 28. You can check in calculator as well. Then it will be half of that, 14. Remember, this area formula is given. You have to use the exact same one. Not determinant is not the answer. Area over here needs to be found by half times whatever is the determinant. And here as well, I'll just do the next problem, the last one. Same thing, it's 13.5. And let's do this. First, step 1, determinant x. Let's bracket. Now what we do is we write x1 7 3 1, 6 minus 1 1, and lastly 1 minus 3 1, and this repeats 7 6 1 and 3 minus 1 minus 3. Now it's always from upside to downside. It's minus 7 plus 3 minus 18 subtracted by minus 1. 7 times 3 is 21, it's negative 21 and plus 18. Next what we do is we add them up over here. It will be minus 4 minus 22, and here we have minus 22 plus 18, that's 4. Let me just double check it. 18 minus 2, it's minus 4. Minus minus will be plus, so it will be minus 18. And now step 2 is area. Area is half times, you should write the formula and everything, minus 18. So it will be half times 18, that is 9. 9 units square is the area. Let's check the answer. Here you go. You have to do the determinant, and it was 18, but subtract negative 18, and then you use determinant, so it becomes positive 18, and solve it up. Half times 18 is 9, and that is the same answer which we got as well. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.